Similar triangles and indirect measurement. Remember back in the day we worked with triangle congruency shortcuts. And some triangle congruency shortcuts that we worked with were side, 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 angle, and angle, angle, side. And if in those triangle congruency shortcuts, if we knew that those corresponding sides were equal or corresponding angles were equal, then those two triangles were congruent. Well, there are a handful of similarity shortcuts, and one of them that we're going to focus on today is the AA similarity. And the AA similarity triangle shortcut says if in two triangles, if two pairs of corresponding angles are congruent, then the triangles are similar. For instance, if this is all I know about two triangles, that they have two corresponding angles that are congruent, then that's all I need to know that these triangles are similar to each other. Now, if with the triangle angle sum theorem, I already know that if these two angles are congruent to these two angles, then their third angle is going to be congruent to each other. But with a triangle, if all three angles are congruent to another triangle's three angles, then those sides are automatically proportional. There's no other way to fit three sides of a triangle together with those same angles. It's no way to set those sides up not proportional. So we're going to do some problems that we don't know that the triangles are similar, but we can tell they are similar by the AA similarity shortcut. For instance, a problem like this. In this problem, I want to find the missing sides. Well, side, it's really singular, side. Find the missing side. So I'm not telling you in this problem that the triangles are similar, but I can tell because remember vertical angles. And so because I know that, then I know that these two triangles are similar. I know that triangle FIJ is similar to triangle, starting with this triangle with the same kind of angle, the congruent angle to FG, going to the 90-degree angle, H. So I wrote a similarity statement, and I'm going to base my proportion off that to find the missing side. So I'm going to compare FI to FG, and then I'll compare FJ to FH. So FI over FG is equal to FJ over FH. Plug in the sides I know. 9 over G equals 15 over 10. Now, one way to solve this would be to do cross multiplication. There's other ways to do it too, because you can see that this is 3 to 2, but we're going to do cross multiplication here. So we'd have 15G equals 90. Divide both sides by 15, and 15 goes into 90 6 times. So G has a measure of 6 meters. So there's an idea of indirect measurement using this idea of AA similarities. Kind of like a typical geometry word problem that you get in a section involving similar triangles. Is when you have kind of nesting triangles like this. You have triangles that have the same, 90 degrees, and then they have a shared angle. So what's happening here is I have triangle ECD, and it's nested inside triangle FGD. And those two triangles are similar because of angle, angle, similarity, angle, angle. So if I wanted to find N, and I wanted to write a similarity statement, I would do triangle DGF is similar to triangle DCE. And those angles are all corresponding with each other. See, D and D are lined up, and then the 90-degree angles are lined up. And then I can set up, once I have that, I can set up my proportion. So I would do, so I'm going to do DG over DC, because I know both of those. And then I will do GF over CE, because I'm trying to find GF. So DG over DC equals GF over CE. DG, when I want to plug in the information I know, is 6, DC is 3, GF is N, that's the one I'm trying to find, and CE is 4. So I'm going to solve it a different way. I'm not going to do the cross multiplication because I can see right here 6 over 3 reduces to 2 over 1, and that's the similarity ratio. And so this one's going to have the same relationship. I just need to multiply 4 by 2, and I would find n. So n is equal to 8 meters. So here we're going to get into some word problems that you might see. And in all of these word problems, I really want you to draw a picture. You need to draw a picture to help you visualize what's going on in this problem. So we'll do the first problem together, and then the second problem I'm going to have you do on your own. So for the first problem, an observation tower is 16 yards tall. Its shadow is 30 yards long. Close by there is a marble column that is 8 yards tall. How tall is the marble column shadow? So here's my observation tower, 16 yards. Its shadow is 30 yards. And then close by, it says, we have this marble tower that's 8 yards. We're going to nest those two triangles together. And we want to find out how long its shadow is, x. And so we know that these two triangles are similar. This one, the small one, and this big one, they're similar. And so I'm going to set up a proportion. I'm not going to write a similarity statement. I'm not going to write my proportion. You can totally write that out if that's going to help you organize your thoughts. But in this problem, I'm going to do it a little bit faster because I'm going to take the heights of these towers and columns. So 8 over 16, I did the small one over the big one. And then I'm going to do the same thing for the shadows, x over 30. And I'm going to solve this a simple way because I see right here this reduces to 1 over 2. So that means that this is going to have the same similarity ratio. If I just take 30 and divide it by 2, I get the value of x, which is 15, and it's 15 yards. Okay, so what I would like you to do is pause the video, read the second problem, solve it, and then press play and check your answer with mine. Okay, welcome back. I drew my little picture. I got away with not writing a similarity statement. I just took the height over the height equals the shadow over the shadow, and I solved for x, and I got x was 3 yards. I hope all this helps with the practice problems. When you're working on them, let me know if you have any questions. Thanks.